So matrices, first question, for what value, okay, should I write the, okay, for what value of x, the matrix 0 1 minus 2 minus 1 0 3 x minus 3 0 is a skew symmetric matrix. Skew symmetric matrix. What is the meaning of that? When transpose, it will become negative. That is, A transpose is equal to minus A. That's what a skew symmetric means. So let's transpose it. 0 minus 1 x 1 0 minus 3 minus 2 3 0 is equal to minus A. This is matrix A. Okay, I have transposed it and written left hand side. Minus A, which is 0 minus 1 plus 2, 1 0 minus 3, a minus x 3 and a 0. So then they both has to be equal. So x is equal to 2. Here also x is equal to 2. So that's all. This is how you find it. Okay, so that's the first question's answer. So let's go to second question. If A is a skew symmetric matrix, show that A square is symmetric. Whenever something is symmetric, you have to take that. To prove that, you should take that. So A square and transpose it, correct? A square the whole transpose, which can be written as A into whole transpose, which can be written in descending order, like this A transpose into A transpose. It doesn't matter. But then A is a skew symmetric, which means A transpose itself is minus A. So minus A into minus A. Thus you get an plus A square. Thus A square when transpose become plus A square. So then therefore A square is a symmetric matrix. Okay. So that's the second question. The third question, if a matrix 0 A 3 2 B minus 1 C 1 0 is skew symmetric, find the value of ABC. Find ABC. You know, A transpose is equal to minus A. So what is A transpose? 0 2 C A B 1 3 minus 1 0 is A transpose, which is equal to minus A. So 0 minus A minus 3 minus 2 minus B 1 minus C minus 1 0. So thus you know that A is equal to minus 2, C is equal to minus 3. Yeah, that's all. So that's the 14th question. A is equal to minus. What about B? B is equal to what is in the place of B? Here B is equal to minus B. That is where it's so tricky. Therefore B has got to be 0. That's when B will be equal to minus B. So that's a beautiful sum. Okay, so sure we're done with it. Next question. If A and B are symmetric, which means A transpose is A and B transpose is B, show that AB plus BA is a symmetric matrix. It's a symmetric matrix. What do? Just take this and then AB plus BA whole transpose, which is AB the whole transpose plus BA the whole transpose, which will be B transpose into A transpose plus A transpose into B transpose, which itself is BA plus AB. So you transposed, you got back the question. So then therefore that's it. Okay, so then that's about it. Similarly, a fifth question, if A and B are symmetric, of the same order, that's very important, okay, of the same order, Prove the following matrix is skew symmetric. AB dash minus BA dash is skew symmetric. You have to prove this. So you take this AB dash minus BA dash and whole transpose it. So it will become AB dash the whole transpose minus BA dash the whole transpose, which will become B transpose into A transpose minus A dash the whole dash into B dash, which is B dash into A dash minus AB dash. And you know that B dash is B and A dash is A, minus A is A, B dash is B. So it is minus of AB minus BA. But you need AB dash as it is, right? You did AB dash minus BA dash and you're supposed to get back the question, which is minus of AB dash minus B dash A dash, which is minus of AB dash minus BA dash. Only one place you apply, another place you don't apply. You know what I'm saying? So that it becomes a skew symmetric. Just manipulate accordingly so that you get it to be skew symmetric. Okay. So sixth question. What else I can give you? If A is equal to cos alpha sin alpha minus sin alpha cos alpha, find the value of A dash into A. What is A dash? Is transpose this cos alpha minus sin alpha cos alpha into A, which is cos alpha sin alpha minus sin alpha cos alpha, and A transpose into A. Okay, so first row first column, which will be cos square alpha plus sin square alpha 1, first row second column, cos alpha sin alpha minus sin alpha cos alpha 0. So I think the answer will be I. And you know A into A transpose, we know A into A inverse is I. Okay, A into A transpose, the first time we are coming across. Second row first column is 0 and second row second column is 1. So thus you get the sixth question's answer to be I. Hopefully I am right. Okay, so just verify my answers. So next is next question. Show that the matrix which is both symmetric and skew symmetric, which is both symmetric and skew symmetric, is a null matrix. So you have to prove this. Okay, so how do you prove this? Let a matrix is symmetric, A transpose is A. A skew symmetric, A transpose is minus A. So what does it mean? That it means that equating this, A is equal to minus A. So 2A is equal to 0. So A will be equal to 0. Thus a matrix A, which is both symmetric and skew symmetric, will be equal to a null matrix. Can you see it is A matrix itself has become 0? Such a beautiful proof, very important. Okay, so what else I can ask you today? Find the inverse of a matrix, inverse of 2, 1, 4, 2. So you know the formula for finding A inverse is 1 by determinant of A into edge of A. 1 by determinant of A is just the determinant of this matrices, which is 2 to the 4 minus 4. So determinant is 0. So you can't inverse, it's a non-invertible matrices. What? Find the inverse of the matrices. 1 by determinant of A into edge of A. 2 to the 4 minus 4 itself is becoming 0, which means this inverse does not exist. One second. So yeah, inverse does not exist. So let's go to next question. Find the inverse of this matrices 9, 5, 7, 4. It's 1 by determinant of A into edge of A. So let's find determinant of 9 4s are 36, 7 5 is 35. It will be 1. So the 1 by determinant of A is 1. How to find edge of a matrix? 9, 5, 7, 4. How to find the edge of this? First you close this and write this. This is A11. Here you write A11, A12, A21, A22 because it's just a 2 by 2 matrices. Okay. So A11 itself is 4. A12 means you close this and this, write 7, but it's odd. 1 plus 2 is odd, so write minus 7. A22 is close this, you get 5. A22, okay, A21, A22 means close 1, you get 9, and which is a odd in positions, you have to write minus, and you have to transpose and write 4 minus 7 minus 5 and 9. So now I am going to teach you a shortcut to find this. Can you see that basically for a 2 by 2 matrices, these two have got interchanged, and you inserted negative sign here to find the edge of a matrices. So edge of a 2 by 2 matrices, there is a shortcut. You don't have to really sit and calculate. Okay, whenever they give you, just exchange these two and change the symbol of these two. So as soon as you get it, 4, 9 minus 5 minus 7, that's all will be the edge of a matrices by 1. Therefore this itself is A equals. So I hope you learned the shortcut. It's very important to have learned the shortcut. That's applicable only for a 2 by 2. One plus sin theta 1 plus cos theta 1. Okay, this is the question, and you have to find the maximum value of theta. 41st, 1 second. Find the maximum value of this determinants. Find the maximum value of this determinants. That's all. Okay. So how do you find the maximum value of this determinant? You just expand this determinants. Okay. So before expanding, I would like to use property. The moment I see 1, 1, I'll do rho 2 is rho 2 minus rho 1, rho 3 is rho 3 minus rho 1. Whatever it is, even the property is not there, I would like to use that. So this will become 0, this will become just a sin theta, this will become 0, this will become just a cos theta, this will become 0, this will become a 0. The advantages I can expand along this when it's positive. So top to bottom minus bottom to top, 1 into. So I'll just get a sin theta minus sin theta cos theta. So this is my determinant value, and for this value to be maximum, when will this be maximum? I want either okay, this can be written as sin 2 theta by 2 with a negative sign. Yes, and you all know sin 2 theta's value always lies between minus 1 and plus 1. Any sin value or cos value lies with minus 1 plus 1. You're going to divide every side by 2, so that you get and you're going to put a minus inside. So when you put a minus inside, minus sine 2 theta by 2, the symbol will also become changed and it gets like this. Yeah, so then therefore can we say that it lies between minus half and plus half, and so the maximum value is this half of the determinants, okay, of maximum value of the determinant is this. So next question is the 11th question. If the area of triangle with vertices minus 3, 0, 3, 0, 0, k is 9 square units, find the value of k. Find the value of k. So how do you do this? Area formula is half of x1 y1 1, x3 y3 1, x1 x2 y2 1, x3 y3 1. So you can expand along any of this, which is equal to 9 units. So to find unknown value, this has to be taken that side, written 18, and you have to convert it as plus or minus 18. You can expand along this, so it's a negative k into minus 3, which is minus 6k is equal to 18, plus or minus 18, right? So k therefore can be 3, or k therefore can be minus 3. K can be plus or minus 3. So that's about this question. So let me figure out what question. Next is 12th question. Find for what value of lambda, for what value of lambda the matrix is singular. Matrix is singular. Let's find for what value of lambda the matrix is similar. It's 1, lambda 0, 3, minus 1, 2, 4, 1, 5 is singular. Similarly, next is sum is for what value minus 2 sin x, 3, 1, 2 sin x is singular. For what value of x? For what value of x? So you just have to find the determinant, and singular matrix is equal to 0, and hence find the value. Okay. So first question, the lambda here has got to be minus 1. The second question, x here has to be 2 pi by 3. You can check out your answer. Determinant value is equal to 0. So in this case, if its determinants is 4 sine square x minus 3 is equal to 0. So sine square x is equal to 3 by 4. So sin x is equal to plus or minus root 3 by 4. Okay, so then it's plus or minus. Sign can be positive or negative in the third, first, second, third, fourth. Yeah, so I should be writing all answers, right? It's been specified in the question that x lies between pi by 2 to pi, which means if x lies in second quadrant, that's when it will be positive. So the value of x is just whatever is in the second quadrant. So that's why answer is 2 pi by 3. I hope you understood. These are the sums for today's paper. Very short question, but I hope you can get full on this.